Hello 8th graders and happy Thursday. Today we're going to start talking about one of the most important topics in 8th grade, and that's lines and linear equations. We're going to use what we know about similar triangles to find slope. Let's dive right in. First, draw the translation of point P 5 units left and 5 units up. Once you've drawn that translation, enter the ordered pair for P' into the boxes. P' is located at -2, 3. Now draw the reflection of point P over the x-axis. After you've done that, enter the location of P' in the boxes. P' is located at 3, 2, 2 spaces away from the axis, and now it's in quadrant 1. Draw the reflection of point P over the y-axis. After you've done that, enter the location of P' in the boxes. P' is located at -3, -2. Now let's draw a dilation of the quadrilateral with a scale factor of 3 that's centered at the origin. To be able to do that, first we need to know our original ordered pairs. Go ahead and enter the locations for point L, point M, point N, and point K. Point L is located at 0, -2. Point M is located at 1, 3. Point N is located at -2, 3. And point K is located at -3, -2. Now, to draw my dilation, I need to multiply each ordered pair by the scale factor. What will be the new ordered pairs for L', M', N', and K'? L' will be located at 0, -6, M' will be located at 3, 9, N' will be located at -6, 9, and K' will be located at -9, -6. Go ahead and draw the dilation of this figure now. Check to see that your dilation looks like mine. Today we will use simplification when we find the slopes of lines. Let's simplify 4 over 6. First, what's the greatest common factor of 4 and 6? What's the largest number that I can divide both by? It's 2. If I divide both 4 and 6 by 2, what's my new fraction in simplest form? It's 2/3. Now I can simplify 3/9. What's the largest number that I can divide both 3 and 9 by? What's the greatest common factor? It's 3. When I divide both by 3, what's my fraction written in simplest form? It's 1/3. Now I can simplify 30 over 50. What's the greatest common factor of 30 and 50? It's 10. When I divide both by 10, what's my new fraction written in simplest form? It's 3/5. Now let's dive into today's lesson. Today we're going to talk about slope. Slope is the measure of steepness of a line, or its rate of change. We can use slope triangles, or triangles drawn along the line, to calculate the slope by finding the quotient of the vertical side divided by the horizontal side. This quotient can be written as a fraction. When you see slope in equations for lines, it will always be written as a whole number, a proper fraction, or an improper fraction. Let's start by doing some examples. The triangles on the grid to the left are slope triangles. They're slope triangles because the long side is formed by the same line. These triangles are similar because they are dilations of one another. Let's look and see if we can find the slope of this line. What is the side length of BC, the vertical side of the first triangle? It's 3. What is the length of AB, the horizontal side of the first triangle? It's 4. To find the slope, we need to find the quotient of BC divided by AB, the vertical side divided by the horizontal side. How would I write the result of 3 divided by 4 as a fraction? It's 3/4, my dividend, over my divisor. We can find the same slope using any triangles on the line. What's the side length of ED, the vertical side of the largest triangle? It's 6. What's the side length of CD? It's 8. What's the quotient of ED divided by CD? Or what's 6 divided by 8? Go ahead and write that as a fraction. 6 divided by 8 is the same as 6/8. I know that I can simplify 6/8. What's the largest number that I can divide both 6 and 8 by? It's 2. When I simplify the fraction, what do I get? I get 3/4, the same slope with a different triangle. The slope of a straight line doesn't change, and I can use any triangle along that line to calculate the slope by dividing the vertical side length by the horizontal side length. Now let's try a couple examples. Look at the triangle on the left. What is the vertical side length? It's 1, 2, 3. What is the horizontal side length? It's 1, 2. What is the slope written as an improper fraction? Well, what's 3 divided by 2? 3 divided by 2 is 3/2. Let's do another example. What is the vertical length of the triangle to the left? It's 1, 2. What is the horizontal length? It's 6. To find the slope, I can divide the vertical length, 2, divided by the horizontal length, 6. How would I write that as a fraction? It would be 2/6. I can simplify that fraction. What's the greatest number that goes into both 2 and 6? What's the greatest common factor? It's 2. When I divide both 2 and 6 by 2, what do I get? I get 1/3. The slope of the line is 1/3. Now you try a couple examples. For the triangle on the left, what is the vertical length, the horizontal length, and the slope written in simplest form? The vertical length is 5. The horizontal length is 5. So the slope of the line is 5 divided by 5, or 1. Let's try another. What is the vertical length, the horizontal length, and the slope of the triangle on the left? The vertical length is 3. The horizontal length is 6. When I divide 3 divided by 6, I get the fraction 3/6. The greatest common factor is 3, and when I simplify, the slope is 1/2. Sometimes we'll be given lines that don't have triangles drawn in. To find the slope of these lines, first identify 2 perfect points on the graph. I see a perfect point right here and a perfect point right here. A perfect point is any place where the line crosses exactly where 2 spots meet on the grid, where 2 lines meet on the grid. So I can fill in my triangle. What is the vertical length of the triangle that I've drawn? It's 2. 1, 2. What is the horizontal length of the triangle that I've drawn? It's 1. What is the slope? The slope is 2 divided by 1, which is the same as 2. Remember, I can find the slope by dividing the vertical length by the horizontal length. Now let's do another line. Find 2 perfect points on that graph. Then find the vertical length, the horizontal length, and the slope. Enter your slope in the box. For this example, you could have found a triangle with a vertical length of 1 and a horizontal length of 4. Or you could have found a triangle with a vertical length of 2 and a horizontal length of 8. Either way, that would have led to a slope of 1/4. The slope of this line is 1/4. Sometimes we'll be given a graph where the scale is not 1. In this instance, the scale is 10. I can still find slope the same way, by dividing the vertical side length of a triangle by the horizontal side length of a triangle. First, let's find 2 perfect points on this graph. I can see a perfect point at 10, 40, and I can see a perfect point at 40, 50. Go ahead and draw in your triangle. What's the length of the vertical side? Well, 1 times 10 is 10. What's the length of the horizontal side? Well, 3 times 10 is 30. I can find the slope by dividing the vertical side by the horizontal side. 10 divided by 30. How would I write 10 divided by 30 as a fraction? It would be 10 over 30. I can simplify that fraction. What's the greatest number that goes into 10 and 30? It's 10. When I simplify the fraction, what is my new fraction? What is the slope of this line? It's 1/3. The vertical side divided by the horizontal side. We'll do one more together and then you can try another one on your own. What is the vertical side? What is the horizontal side? And what is the slope of this line? First, find 2 perfect points. I can see a perfect point at 30, 0, and at 60, 20. What is the length of the vertical side of the triangle? Well, 2 times 10 is 20. What is the length of the horizontal side? 1, 2, 3 times 10 is 30. I can divide the vertical side by the horizontal side to find the slope. What's 20 divided by 30? Written as a fraction. It's 20 over 30. What is the largest number that I can divide both 20 and 30 by? It's 10. When I simplify 20 over 30, what's my new fraction? What's the slope of this line? It's 2/3. Now try one on your own. What's the slope of this line? The slope of this line is 4/3. The vertical side length of the triangle could have been 40 or 80. The horizontal side length could have been 30 or 60. When I divide 40 divided by 30, I get 40 over 30. And when I simplify by 10, I get 4 over 3. You did a great job on this video. Now go to IXL Practice Y.1 to practice finding the slope of lines.